Hello students, welcome to Eshwari channel. Students, in this video we are going to learn how to find the stability of resonance structures. So when two or three resonance structures are given, how to find which is more stable. So let us take one example and understand first. So take CH2 double bond CH, single bond CH, double bond CH2. So this is 1,3-butadiene. So here you know that when alternate double and single bond are present, it is called as conjugated system. So what is conjugated system? So conjugated system means if there is alternating double and single bond, we call that as conjugated system. So when there is conjugated system, resonance will take place. That is, this pi electrons will shift here. This pi electrons will shift on this carbon. So you can write this as CH2, single bond CH, double bond CH, single bond CH2, negative sign here and positive sign here. So this is one structure and this is second structure. So now we have to find which is more stable. So between 1 and 2, which is more stable we have to find. So to find that, students, what you have to remember is, if it is a neutral structure will be more stable compared to structure having charge. So here between structure 1 and 2, you can see this is neutral structure. So you cannot see any charge on this. Whereas here you can see plus sign and then there is minus sign. So this is a structure having charges. Therefore, structure 1 will be more stable compared to 1. So stability, if you have to write, resonating structure 1 will be more stable when compared to 2. So this is how we find. So students, we will take some more examples and we will find which is more stable. So first example is this. So students, this example I have taken from the textbook. Problem 12.17. Write resonance structures of the given molecule. Indicate relative stability of the contributing structures. So first part is you have to write resonance structure. Second question is we have to find which structure is more stable. So first we will write the resonance structure for this. CH2 double bond CH, C double bond OH. So CHO, I have written C double bond OH. So oxygen will be having two lone pair of electrons. So now this pi electrons will shift here. This pi electrons will shift to oxygen. CH2, single bond CH, double bond C, O minus and then hydrogen. So here this lone pair of electron and here positive sign will be there. So now instead of this bond shifting, this bond can shift. So when this bond shifts here, this will become double bond and this bond will shift to the carbon. So it becomes CH2, negative sign, single bond CH, double bond C and here single bond O and then there will be a positive sign. When this bond shifts, oxygen gets positive sign and then hydrogen. So this two lone pair of electrons. So this is structure 1, this is 2 and this is 3. So there are three structures. We have to find which is more stable. So how to find? Students, we have two rules you have to remember. First is called as octet rule. Octet rule meaning is all the atoms in the structure should have 8 electrons and hydrogen should have 2 electrons. So this is octet rule. Second rule is electronegativity rule. So electronegativity rule is if positive charge is present on less electronegative element, then it is stable. Or if negative charge is present on more electronegative element, then it will be stable. So how to apply these two rules we will see in this example. So first what we have to check is octet rule. Whether all the atoms in the structure have 8 electrons, we have to check. So students, so here carbon has 4 electrons. This carbon also has 4 electrons. So here the octet structure is complete. Whereas here, see this carbon has only 6 electrons. Why? If I write the expanded form of this, it is written like this. Carbon, 2 hydrogen atoms, 1 hydrogen, 2 hydrogen, and then this bond. So see how many electrons are there? 1, 2, 3, 4, 5, 6. So there are only 6 electrons. So carbon is having only 6 electrons. And oxygen has 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons. So even this carbon has 8 electrons. So 4, 5, 6, 7, 8. So here also octet is complete. So here structure 1, if you see, the first thing what we have to apply is neutral structure. So among this 3, this is neutral structure. This is neutral. So always neutral structure will be more stable compared to charged one. So we can directly write structure 1 will be more stable. So between 2 and 3 we will find which is more stable. So octet, if you see here, carbon doesn't follow octet rule because only 6 electrons are present, whereas here all the atom will be having 8 electrons. So according to octet rule, this satisfies octet rule. Therefore 3 is more stable when compared to 2. Why? Because it follows octet rule. Octet rule. So first is neutral. Structure is neutral. It will be more stable compared to charged one. So I wrote first as stable. Second is this follows octet rule. Therefore this is more stable compared to this one. So here we are applying the first rule, which is called as octet rule. So we'll take one more example. Second example. So second example is H2N CH positive sign O CH3. So this is the example. So now we will write resonance structure for this. So this electron will shift here. So as a result you will be getting positive sign here, double bond CH O CH3. Next, instead of this electron shifting, if this electron shifts here to this, so it will be H2N CH double bond O CH3. So this bond we are shifting here. So here this will get positive sign. So this is structure 1, this is 2 and this is 3. So now we have to find the stability of this resonating structure. So find whether neutral structure is there. No, first point we have to apply neutral. So there is no neutral structure, all are having charges. So second we have to apply octet rule. So we will apply octet rule now. So here nitrogen 1, 2, 3, 4, 5, 6, 7, 8. See this carbon 1, 2, 3, 4, 5, 6. So carbon is having only 6 electrons here. Oxygen has 8 electrons. So nitrogen has 8 electrons, carbon has 8 electrons, oxygen 8. So octet is complete here. And here carbon has 8 electrons, oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So octet is complete. So only here the octet structure is not complete. So this will be not stable, whereas this two will be more stable because it follows octet rule. So between these two, we have to find which is more stable. So now we will apply the second rule. The second rule is, so see here we have positive sign. So positive charge. So if positive charge is present on less electronegative element, then it will be stable. So here positive sign is present on nitrogen. On nitrogen you have positive sign. Here on oxygen there is positive sign. So you know that oxygen is more electronegative than nitrogen. Electronegativity, if you see, electronegativity. Oxygen is more electronegative when compared to nitrogen. So here positive sign should be present on less electronegative element. So less electronegative element is nitrogen. So nitrogen should have positive sign. See here. So oxygen has positive sign, nitrogen has positive sign. So therefore this is the one which is having positive sign. Less electronegative element having positive sign. So this will be stable when compared to this one. So the answer is second will be more stable than third one. Why? Because of electronegativity. Positive sign present on less electronegative element. Therefore this will be more stable compared to this. So now third is more stable than first one. Why? Because here it doesn't follow octet rule. Therefore this will be less stable. So this is how we find the stability of the resonating structure. So students, I'll give you one question. So write in the comment section if you have understood the concept, whether the given molecule, write the resonating structure and say which is more stable. So this is the structure. So first what you should do is write the resonating structure and find which is more stable. So I'll write the resonating structure for you. You find which is more stable. So this electrons will shift here, this will shift here. So you will be getting here and positive sign here. So this is structure 1 and this is structure 2. So students, homework for you is find which is more stable. Structure 1 is more stable or structure 2 is more stable. Write your answer in the comment section. So I'll meet you in the next video, students. Bye.